So what we're going to cover today, so the first test was on part of Chapter 1, most of Chapter 2, and then part of Chapter 3. We're now going to hop into Chapter 4. It's on inequalities. We're going to cover Chapter 4 and Chapter 5 before the next test. I've got those entered into SIS, so if you've logged on, you can see what's due and when, or you can just look at the calendar. Either way is fine. So we're going to start Chapter 4. It's on Inequalities and Applications, and again, I've got a couple problems to do toward the end there, so don't close your books or anything when we're done. So the first question is, what's the difference between this expression right here and that expression right here? Yeah?
One's equal to, so it's going to equal number. The other one's an inequality, so it's going to do everything probably less than that.
Okay, so this one is equal to, this one is not equal to. It says this stuff is greater than that, or equal to it. So these have names though. If it's got an equal sign, what do we call it? So this is an equation. Whoops. This is an equation. And this is called, this has a name also, inequality. Called an inequality. Okay, so here they're equal, here they are unequal. Okay? So, again, a lot of the stuff that you're going to see in this class is review. I think nearly everybody in here has had Algebra 2 before. So you will have seen this before, but there are some mild details that are missed a lot. People tend to forget. And if we can go back and we can solidify these, one, you're going to get a better grade, and two, you're going to do better in the next couple math classes that you're going to take. So again, go at it with the right attitude. Even if you've seen it before, make sure you're getting 100%. Did anybody get 100% on the test? Yes. Okay. Yeah. We had a couple that were pretty far up there. That should be your goal. If you've seen this and you think this is easy, get 100% on all the tests. So, first question is, how do we solve inequalities? Okay, and I've got this little phrase that I teach so people can remember how to solve inequalities. We solve inequalities just like we solve equations. And then let's think about this other stuff. Except when we multiply or divide by a blank, except when you multiply or divide by a negative. If you multiply or divide by the negative, you switch the, careful here, we want to be really specific. We switch the direction of the inequality. So this is an equality. This, whoops, that, we'll do this guy, and that. Those are all inequalities. So we just switch the direction, okay? So if you learned like I did, you were taught the big alligator eats the big number, all that sort of stuff. I don't care how you remember it, but these are the inequalities and we just have to switch the direction there. So if we solve this one and we graph it, this is an equation. When we solve an equation, our goal is to get the variable on one side and number on the other side so we can just read it off. So if we solve this one, whoops, I'm going to subtract 7. Having trouble writing today. That goes away. I get negative 3x. On this side, I get negative 12. Divide by negative 3. So I get x equals negative 4. The answer to that equation is negative 4. That's it. It's just that.
No, it's 4.
Oh, I missed a sign, did I? Good thing you guys are around here. Okay, so the answer is x equals 4. So I've got a number line here. I'm going to put a 0 right here. Always important to put 0 on your number line so everybody knows at least we've got one reference point. And then 1, 2, 3, 4. So we're right here. I just put a dot right there. That's it. Now we don't do that very often. We very seldom graph answers to equations like this. Okay? We do if they're like a 2-variable equation, like x's and y's. We can graph a line or something. That's it for that one right there. If we're going to graph this one, we go about solving it the same way. So negative 3x, this would be greater than or equal to, help me out here, make sure I don't make any silly mistakes. Same steps. I subtracted 7 from both sides. Now when I subtract 7 from both sides, do I need to change the direction of that inequality? Nope, because I didn't multiply or divide. Now I'm going to divide both sides by negative 3. This is going to be x. Gosh, I did it again. Divide by a negative. This is going to be, let's see, negative 12 divided by, get a 4 there, right? And I have to switch the direction here, so this is less than or equal to. So I'm going to put 0 on here again. 0's right here. I'm going to go over to 4. I'm going to label the 4 and I'm going to circle the answer that's at 4. And then I want to read this. This says x is less than or equal to 4. So any number you want, as long as it's less than or equal to 4. If we were going to graph this, we have to do some shading. So I'm going to shade the less than side. Which side is less than 4?
Towards the left.
Okay, towards the left, right? Towards the negative. So I'm going to put an arrow on that. I like to shade in like this, and you'll see why in the next section. Now, are we done with this one? Okay, on this particular one, no, and here's why. You'll notice that when I graphed this one, I filled in the circle. I put a dot at 4 and I filled it in. Does 4 count as one of the answers here?
Yes.
It does, so I'd want to fill that in. Okay, so that's the answer. Again, if the step you take to solve the equation is multiplying or dividing by a negative, you've got to switch the direction of the inequality. Okay, so next one. It says when we solve an inequality, we usually get many answers that will work. That's the difference between the two of these. Here, only one answer works. Only one answer can you plug in and make the equation true. And here, anything you want to plug in that's less than 4, if you plug it in here, this expression will be bigger than -5. Okay? So we can't write down all the answers, so we use inequalities or we use pictures to indicate where they are. And many times we use something called set builder notation or interval notation. Now we've used this a little bit already, but we just want to make sure that we're clear on how to do this. So here's how we'd write the answer to part B in set builder notation. The variable is x, so we have these set brackets, and I write down x. This vertical bar right here literally is interpreted this way, such that. It means those words. So x such that, and then we just write down the answer, such that x is less than or equal to 4. Any questions? Okay, that's called set builder notation. So in the next example, I've got a different type of interval. It's kind of like having a two-sided inequality. So I've got -3 less than x less than 5. Okay, I'm going to mention down below, it's usually best if you read an inequality from the variable. So I'm talking about the x's that are greater than -3, and at the same time they've got to be less than 5. So first thing I'm going to put over here is I'm going to put a 0. Always got our reference point on there, so we can tell which side we're on. Here's -3. I'm going to put a circle there and label it as -3. Here's 5 right here, and I'm going to circle that. Now, can it equal either of those 2 points? No, it doesn't say. It's got to be greater than -3 and less than 5. Okay, so those are going to be open circles. And then it's going to be everything in between here. So I'm going to shade it like that. So that's what it would look like if we graphed it. If we wrote it in set builder notation, again, we indicate what variable we're using. We're using the variable x. And then we just write down what the answer is. This is really easy. That's set builder notation for that particular answer there. Okay, and then interval notation. Again, most of the time we're going to be using interval notation. Once you get past Math 1010, you use it almost exclusively. Okay. I mean, they're both useful, but interval notation is really nice because all you have to do is start from the left, go to the right. Or remember when we were doing domain and range, you're doing the range, you start at the bottom and go to the top. So you start down here and you just write down, where do we start getting answers? Start at -3, then put a comma. Where do we stop getting answers? Stop at 5. And then you just have to figure out whether or not you put round or square brackets around there. Because neither one of these are included, we put round brackets. We put parentheses around it. Now, if this was equal to 5, we'd fill in. Equal to 5 here, we'd put a square bracket around that. Okay. Any questions? Okay. Then let's take a look at the next little bit. On example 3, it says, graph the following, then write in interval notation. So There's nothing really to solve here. All we're going to do is just graph it and write it in interval notation. So I'm going to put a 0 here. Here's a -1. I'm going to circle it. Am I going to fill it in? I am going to fill it in on this one. Okay? Then I'm going to go to 6. I'm going to label the 6. I'm going to circle the 6. Do I fill it in? I do. Because this says 1 is less than or equal to x, and x is less than or equal to 6. And it's all the stuff in between here, because they need to be bigger than -1 and at the same time less than 6, so it looks like that. That's what the graph would look like. If we write down the answer in interval notation, again, you just write down where do we start getting answers, comma, where do we stop getting answers. So on this one right here, we start at -1, comma, stop at 6, round or square around the -1? Square, and what about the 6? Square there also. Okay? Let's look at the next one. Again, pretty quick. I've got 0 here. I've got -5 here, and I've got -2 here. Doesn't necessarily have to be to scale. Which of these two do I fill in? X is greater than or equal to, so it could actually equal -5. And x is strictly less than, that's the word we use for this. We say it's strictly less than -2. So it can't even equal -2. And everywhere in between. Okay, now please don't get too far ahead. I need you to listen. Write down where it starts. Write down where it stops. Square around the -5. Round around the 2. And there's the answer there. Okay. Please don't mess this up on the test. Saw a couple people with hints of doing something like this wrong. Everybody listening? How close can you get to -2? Like what's the last number that would work? Okay, that's fabulous. I hear tons of mumbling. That's great. Okay, would -3 work?
Yes.
Yes. What about -2.5?
Yes.
-1.99999? No, because -1.999 is over here. It's on this side. So you could get really close to 2, including 2, and it still wouldn't work. What about -2.000001? That would be just barely on this side. So you don't stop at 3. Don't stop at -3. Okay? I mean, you could say -2. How many zeros could you put and then a 1? As many as you want, right? Okay, that would just barely be on that side. So please don't stop at -3. Okay, let's take a look at the next one. It says the set of x's such that x is, or excuse me, it's 1 is less than x. So here's 0. What's the most important point on this number line? A 1. So I'm going to put a 1 here. I'm going to circle that. Okay, now it says this down below. Often you'll see them written this way. It's usually best, whether you're looking at it from the left or the right, doesn't make any difference, but usually it's better if you read from the variable. So even here, we're talking about x's that are greater than or equal to -5 and less than -2. Here we're talking about x's that are greater than 1. So if we're talking about x's that are greater, which side is greater than, left or right? To the right. Okay. Do I fill it in? Nope, I don't. There's the picture. What would the answer be in interval notation, Zach?
-1, infinity, both have parentheses.
Okay, 1, comma, we stop at infinity. Infinity is always a round bracket. It's always a parenthesis. And because this isn't included, that's also a round bracket. Okay, are there any questions there? Make sense? Again, it's very helpful to read an inequality from the variable. Okay, like we did here. Just read this as x is greater than 1. So it says determine whether the numbers are a solution of the inequality. So if you want to know whether or not these are solutions, plug them in and see if they make the inequality true. So if I plug in a -4, that's going to be -4 minus 4 greater than or equal to 1. That's a -8 greater than or equal to 1. Nope. Plug in a 4. 4 minus 4 greater than or equal to 1. Nope, that would be 0 greater than 1, so that's a nope. How about this one right here? If people struggle with something, it's usually this one right here, because this is 5 minus 4 greater than or equal to 1. This is 1 greater than or equal to 1. Okay, it has the word or in there for a reason. It's either got to be greater or it's got to be equal to. So, is it greater than 1? No. Is it equal to 1? Yes, it is. So that one's a yes. And if you plug in an 8, you're going to get a yes there also. Okay? Again, this is the one that people struggle with the most right here, but that is a yes. Okay? Because it can be equal to or greater than, one or the other. Okay, any questions? Okay, let's take a quick look here. These are problems that I pulled out of the textbook. It says, graph each inequality and write the solution set using both set builder notation and inequality notation. Is this hard? Go ahead and do one or the other. I don't care which, but make sure you get it right. Compare your answer with your neighbor. So I'm giving you permission to glance at your neighbor's paper, just kind of compare your answers. If you did the same one, great. Check and make sure you both got it right. If you didn't do the same one, look at theirs that's different from yours and figure out, okay, that I can see that makes sense. Okay, for number 15, it says y is less than 6. So I've drawn an axis. I don't fill it in. Less than is to the left, so I'm shading like this. In interval notation, it starts at negative infinity, stops at 6. I don't include the 6, and I never include the infinity because it's not really a number, it's more of an idea. Okay, so always square around there. And then for this one, x is, again, reading from the variable, x is greater than or equal to negative 4. Equal to means I fill it in. Greater than means I shade to the right. So the graph would look like this. And then interval notation would be from negative 4 to infinity. That's where I start and that's where I stop. And then this would be square. Yeah?
We didn't do set builder notation.
Oh, okay. We'll do set builder notation. Let's see. So set builder notation. There's our set bracket. Here's our y. That means the phrase such that y is less than 6. And for this one, x's such that x is greater than or equal to negative 4. And there's the answer. That's about the best set bracket you're going to get out of me. Okay, mine look like squigglies. Okay, are there any questions on the first page or this stuff right here? Because we're going to speed it up just a little bit and do more interesting problems. We're good? Okay, let's take a look at the next one. I'm not going to do number 23. That one's pretty easy. We are going to look at this one right here. Okay, now let me just point this out so you don't make this mistake. This happens quite often. Somebody will be solving this and they'll say, well, I know what I need to do. I need to get the t by itself. So I'm going to get rid of the 9. So I'm going to divide by 9. That's a piece of cake here. I get t. And then they look over here and they say, well, wait a minute. This is a negative. I get a negative 9 out of this. I better switch the direction of the inequality. Is that right? No, the problem with that is the step we took was dividing by positive 9. Who cares if this works out to be negative? It's the step we were taking that changes the direction. We were dividing by a positive, so it stays the same direction. So this is going to be a less than. And then it says write the solution using both set builder and interval notation. Yeah.
So you don't flip it when it's positive?
When you divide by a positive or multiply by a positive, You do not flip it. The only time you change the direction of the inequality is when the step you're taking to get the variable by itself is either multiply or divide by a negative. And what we were doing here is we were dividing, yes, but not by a negative, so we don't have to switch it. Good? Okay. Anything else? So the nice thing about this is we've done some work. Set builder notation is literally this easy. Put the bar, put the variable, make your little squiggly brackets here. Now, it's for most people, okay, including myself, it's kind of hard to think of, well, what would interval notation look like without actually graphing or thinking of the graph. So the graph would look something like this. Here's 0, here's -9. I'd circle it. It's strictly less than, so I at least need to visualize this. And then the answer in interval notation, where do they start? Careful. -infinity to -9, round around both of them. Okay? Now, everybody listen please, because this is another mistake people make. I chose this one for a reason. Some people will say, let's say you started at -9 and you stopped at -infinity. Is that right? Okay, we do things in order in math. Okay, this is technically wrong. Yeah, I get the idea. If you look at the domain and range problem on the test, there were some people that switched the order. They got the right numbers for the endpoints of the domain or the range, but they wrote them in the wrong order. Okay, so I probably said, -1/2 or -1 or something like that. We do go from left to right. We go from smallest to biggest. Okay, so this is the proper way to write it. Any questions? Okay, so Tyler, how do we solve this one?
Divide by
-0.3. We're going to divide by -0.3. If you divide both sides by -0.3, this becomes an x. This becomes, now see why the logic is flawed here? This becomes a positive. How many times does it go in there? 50 times. Goes in there 50 times. Gosh, this is positive. Do we need to switch it? Yeah, you need to switch it. Okay, here's how I like to do these problems. Everybody listening? Before I even make these calculations, before I even start canceling anything off and figure out, gosh, this side's x, this side's positive 50, before I even do that, I look at this and I say, what step did I just take? Did I multiply or divide by a negative? If the answer to that is yes, switch the direction right away. If the answer to that is no, then don't worry about it. So this is going to switch directions, so it's going to be a less than. Here's set builder notation. Let's see if we can visualize this. 50 would be here. I'd do less than, so we're over here. So this is going to be, help me out here, -infinity to 50, open brackets around both. Okay, any questions there? Okay, would you solve number 40 and check with your neighbor, please? Okay, so I'm going to subtract 8. I'm just subtracting. Who cares what I'm subtracting? I'm not going to change the direction. So this is -x less than 7. I need to make that a positive x, so I'm going to divide by a -1 on both sides. The step I'm taking is dividing by a negative. I do have to switch the direction, so that's going to change to a greater than. That's going to be an x, and that's going to be -7. So in set builder notation, it looks like this. As an inequality, in graphing that, let's see, here's -7, circle that, don't fill it in, shade this side. So in interval notation, I've got -7 to infinity, round around both of them. Okay, any questions? Okay. Sure? Okay, let's take a look at, 41's pretty easy. I'm going to skip that one. Let's take a look at number 46. Okay, if this were an equation, what would we do on that equation to get the x by itself?
-5, sorry.
Okay, multiply by -5. So I'm going to multiply by -5 on both sides. So if you want to write one on both sides, that's fine. It cancels here. Let's see, maybe I ought to figure out whether or not I need to switch the direction. Do I? I do, because look what we did to both sides. We're multiplying by a negative. So this is going to be 3 minus x greater than 10. Get rid of the 3. Negative x greater than, this is going to be a 7. And then finally, I'm going to need to get rid of the -1 in front of that. So I'm going to divide by a -1. So I get x, what is it? Less than -7. So there's the answer. Again, if we wrote it in set builder notation, it looks like this. As an inequality, it's going to be all the numbers that are less than 7, so they start at less than -7, so they start at -infinity, stop at -7, open bracket around each one. Okay, questions? Okay, you've got some problem on Math Excel that are similar to this. It says f of x is this equation right here. G of x is this equation right here. So we've got two separate functions here. And it says find all values of x for which f of x is less than or equal to g of x. So f of x less than or equal to g of x. Any ideas on what we do here? That?
Set them equal to each other, just make sure you put the sign.
Set them equal to each other, just make sure you have the right sign or the right inequality. I'll buy that. Or this is kind of like substitution. If these are equations, we could substitute them. We're doing the same thing here. Wherever there's an f of x, I'm going to put a 7 minus 3x. Less than or equal to, wherever there's a g of x, I'm going to put a 2x minus 3. And then I'm going to solve that. Now, this is the first one we've come across where we've got variables on both sides. And this is another reason why that rule we went over in the last chapter is a good one. Which one should we move? You move the smallest one, or in other words, you move the one that's most toward the negative side. Because if I add 3x to both sides, if I'm adding, I don't need to change the direction. So this is going to be 7 less than or equal to 5x minus 3. I'm going to add 3. So this is going to be 10 less than or equal to 5x. And then I'm going to divide by 5. At no point did I have to multiply or divide by a negative, so I don't have to switch the direction. So the answer is 2 less than or equal to x. Okay, is that the best way to write it or think of it or read it? No. Okay, so it might be a good idea if we read it or thought of it or wrote it from the right side to the left side. So in set builder notation, we're talking about all the x's that are greater than or equal to 2. In interval notation, we start at 2 and we continue going greater and greater and greater. And it'd be a square bracket around here. So here's what the graph would look like. Any questions? Sure? This stuff is all okay? All right. Okay, let's take a look at the next one. Any questions there? Easy enough, right? Same idea as what we just did. Okay, let's take a look at the last little bit, and then we'll look at these other problems here. So, are you sure there are no questions on anything? We're ready to do this stuff right here? Okay, so remember from chapter 2, we talked about functions that have domain issues. And remember, the domain are the numbers that we can plug in. Okay, so normally those are the x's, although we could choose about any variable we want there. Okay, most of the functions that we deal with have a domain of all real numbers. Okay, so you can plug in anything you want from -infinity to infinity. Or you may have been used to writing it like this, kind of like a script R. but not all functions. So we talked about 3 functions, 3 operations that cause issues with the domain. Okay, you can't do this. It breaks some mathematical rules. What was the first one we talked about? Square root's one of them. The first one we talked about was x in the denominator, or in other words, dividing by 0. Okay, so we've got division. We can't divide by 0. That's not allowed. Can't divide by 0. Okay, what was the next one, Christopher? Square root. Okay, I'm going to call them even roots. So you can't take the even root of a negative. Can't take even root. Most of the time we're going to run into square roots, but we'll run into other ones. Even root of a negative. So you can't divide by 0. You can't take an even root of a negative. And then there's one other one. Yeah.
Are we going to go into imaginary numbers in this class?
Not until chapter 7. Okay. Good? Okay, and the other one is logarithms. Okay? You can't take the log of a negative or 0. And I'm not going to spend much time on that one right there because we won't run into those until much later in the class. But just realize if you've got division, even roots, or logarithms, you better be really careful because you can't plug in any number you want. Okay? So notice that we're talking here about things that are negative, or we call them non-positive. Okay? So 0, negatives, things that are not positive. Well, we can actually translate these phrases into inequalities. Okay? So the word positive and the word negative can be translated into inequality. So if we say x is positive, as an inequality, what we mean is x is greater than 0. And if we say x is negative, then what we mean is x is less than 0. So I think we had a few of these before. This says find the domain of each function. Okay, they're not division, so it's not dividing by 0 that we're worried about. Here's what we're worried about. We're worried that this is going to be a negative. So whatever this is, it can be 0 or bigger. Okay, now this is how you say something is positive. How do you say it can be 0 or positive? Greater than or equal to. Okay, so we want this stuff, x minus 10, to be positive. In other words, greater than 0. Or it could be 0. Solve that. That's your domain. So we're going to add 10. Add 10. So I get x is greater than or equal to 10. Any number you want that's 10 or bigger will work in the domain. Anything else won't. And then you could, of course, write that in set builder notation, right? Okay, let's do number 67 then. Whatever that is, we call it a radicand. Whatever that is, we want it to be positive or at the very least 0. So we want to set the radicand greater than or equal to 0, and then we solve. Now, there are 2 ways to solve this. One's easy and one's a bit more complicated. Does anybody see the easy way to do this one? Amelia? Yeah. If we add something, does that change the direction of the inequality? No, it doesn't. So the 3 is left on this side. This is still a greater than or equal to, and there's an x over here. Now, what's the best way to read this? X is less than or equal to 3. Okay? So you'd read that as x is less than or equal to 3. Okay, any questions? Easy enough? Okay, I've got 2 problems here. I'd like you to just look at those, and then we're going to do one of them really quickly. This doesn't take much time. Okay, it's a made-up problem, but they're actually real-life problems here. Jen can rent a moving truck for either $99 with unlimited mileage, and like maybe cell phone plans that are unlimited, or you pay for access and then per minute. Okay, or $49 plus 80 cents per mile. For what mileage would the unlimited mileage plan save money? We want this one to save money. If you save money, have you spent more or less money? Okay, so we want the $99 one. We want this one to be less. We want this one to be more, the other plan to be more. Let's think about how we'd write this down. Here you only have to pay $99. Over here, you pay $49 plus some. Plus how much?
0.8.
Okay, 80 cents per mile, or 0.8 times the number of miles. Is that okay? We want this one to be less. So what do I put in here? An equal to, a less than or equal to, a greater than or equal to? A less than. Because it says we want this one to save us money. If we put equal to, that's right at the even point, the break-even point. Okay? We want this one to be less. Solve that. That will tell you how many miles you'd have to go before the more expensive one is actually less money. Okay? Does that make sense? Okay.